Then some compare instructions. These are the most useful instructions. Is the compare instruction. In the ladder, there is a CMP block equal to greater than equal to, then less than equal to, less than limit, then MEQ, NEQ. You can see the description also. For the functional block, there is some little bit change in the block or the visualization. You can see the equal to, greater than equal to, there is a symbol, greater than, less than equal to, less than, limit, not equal to, or masking equal to, or like that. These are the function. This instruction you can directly browse in the ladder by using these shortcuts. Then CMP is the most useful instruction. Is the compare value based on an expression. In this CMP instruction, you can execute your logic. Suppose you have some transfer function s square plus 2x plus 3, or divided by x plus y plus z, like that. that that type of transfer function you can execute in the CMP block. You can directly put your mathematical transfer functions or mathematical equation into the CMP. That is the benefit of CMP. Except using this all instruction equal to, greater than, or like that instruction, you can directly use the CMP block, and by using this CMP block you can uh, able to configure multiple mathematical calculation in one block, and you can reduce your programming size or page size by using this CMP block. And this is ISINF, means that test whether the source is infinite, test whether the source is not a number, by using these two instructions. If the structure text is text or string is there, you can uh, you use this instruction and compare whether it is number or it is a string. And by using limit instruction, suppose if you have some input values and we want to give that input values as a limit for particular, uh, suppose you are giving some exam. In exam have some limitation, is 0 to 100 score. You can't go beyond that. Only it happens in the gate or negative exams. uh, like it goes negative and it never goes positive, like that. But in BSc Agri, you see most of the time people have positive score more than 100. This type of filters you can use limit instruction, and it never goes beyond the limit or under the limit, and then you can execute your uh, some logic or some calculations, like that. The compare instruction, it look like this. You can type your expression inside this block. This instruction is not available with the function block. It is available only with the ladder diagram, and also it is not available with the function structure text. It is only for the ladder diagram. Then the operands inside the structure text we can use. Here the operation of equal order are performed from the left to right. Is the in bracket, also you can use ABS. These are this instruction you can use. Then two two stars, negations, not, or exclamatory mark. Then multiplication sign, mod sign, division sign you can use. Then subtraction, addition you can use, and or XOR or greater than, less than, equal to, this all you can use. Double and you can use, double power also you can use, mod you can use. This is equal to, greater than, less than, equal to, and this is not equal to. You can remember this one is the not equal to instruction. In the functional block we can say, see the difference in between the FBD, the previous one FBD, and the new one FBD. This the new one is like look like this. The same point you have, the only the few of that block is changed. Then we can go to the compute and mathematical instructions. The mathematical instruction is for the latter is this one, the CPT, add, subtraction, multiplication, division, mod, SQR, SQRT, negation, and absolute value. The functional block is look like this, same. And for the FBD, the newer one is changed with this like one, plus, minus, uh, division sign, percentage sign. For the mod, square root, then negation and mod. For the structure text, only three instruction is available. One is square root RT, then absolute value. This three instruction is available only with the structure text, other not available. You can see the description. The mod is determine the remainder after one value is divided by the another, and square root calculate the square root of the value. Negation is the negative value, the opposite sign of that value, and the absolute is the take the absolute value of value. We are not going to see in detail these instructions, you can go with that directly. Move and logical instructions. In the move and logical instructions, we can see the move instruction MVM. You can see there's some description, but here you can see whatever instruction available for the structure text is MV, MT, swap byte, and bit byte. Okay, we can see MVM. Sorry, move instruction is the copy of value or move strings from one tag to another tag, and copy of specific part of integer is we are going to move masking value. Then copy of specific part of integer in the function block is when we can use mvmt. btd is the move bit within the integer, within an integer or between the integer. We can use the btd instruction. Move bits within an integer or between the integer in the function block, we can use the btdt. The clear value, we can use clear instruction to clear particular tag or instruction. The rearranging of the int, dint, or real tags, we are using the swap bit instruction. This is also most useful instruction when we are going to interface third-party devices. Sometimes the third-party devices have data in a swap bit. That time we need to use this swap bit instruction. Then and or XOR not. Then array instructions. The in array instruction there is few instructions is there. For the FAL, perform arithmetic logic shift and function operation on the values of in the array. Then FSC is the search for and compare values in array. And COP is used to copy the content of uh, one array into another array. To copy data, we are going to use this copy instruction. This copy instruction is very important for the data transferring from one tag to another tag. This is also important for third-party devices configuration or like that, or data copying between uh, one task to another task. Then we can use this copy instruction. uh, CPS is the copy the values in the source to the destination. The FLL fill an array with the specific data. Then AV is the calculate the average of an array of values. We can use the AV. The SRT is the short one dimension of array data into this ascending order. Then STD is the calculate the standard deviation of an array of values. The STD, if you want to find out the size of that array, then you find the size of array by array dimension of an array by using this size instruction. Then uh, array file and shift instructions. Then BSL, BSR, FFL, FFU, and LFU. These are the shift instructions. BSL and BSR, when we use the load bits into shift bits through and unload bits from bit array one bit at a time. The FFL and FFU is loading and unloading instructions from by some order. We can load and unload the array. Load and unload values in reverse order. We use LFL and LFU. These are the inverted of that instructions. And some instruction is there is the FIFO. FIFO is the first in first out instruction. The first in FFL is instruction copies the source value to the FIFO. Then first in first out unload FFU. Then LIFO, the last in first out. Then LIFO, last in first out unload. Then some sequencer instruction is there. One is SQI, SQO, and SQL. SQI is detect when a step is complete, and SQO set output conditions for the next step, and SQL is load reference condition into the sequencer array. Then program control instructions. There is various program control instructions. Jump label, JSR, JXR, return, subroutine, TND, MCR, UID, UIE, SFR, SFP, event, AFI, EOT, and NOF. This JSR, return, subroutine, only these three instruction is available for the function block, and other is not available for the function block. In the structure text, there is JSR, return, subroutine, TND, event, UID, UOT, SFR, UIE, SFP. These are the available for the structure text.